Hey, this is Joe at graybenchelec. Welcome back. Today we're going to do a full kit build on one of the AionFX kits, the Luna, which is a optical tremolo. It's based on the Tremulus Lune. A bit of housekeeping. This is actually the first video I've shot since I hit 1,000 subs. So thank you very much if you subscribed. I really appreciate it. If you haven't subscribed yet, please consider doing so. And also hit the notification bell if you want to know when I make a new video. And also this Luna that we're going to put together in this video is going to be available for sale. Check for the Reverb link in the description, all of the proceeds of which are going to go to humanitarian aid in Ukraine. So let's get started on the build. All right, we're going to do a kit build here. This is the Luna from Ion or AionFX. This is based on the Tremulus Lune, which is a all analog optical tremolo. This version has 6 controls, so lots of features, lots of customization. Dual LEDs, presumably one for indicating the pedals on and off and one for speed. All the components you need, including the PCBs, electrical components, resistors, capacitors, etc., ICs, knobs, hardware, all of that is included, as well as a custom enclosure. The only things that aren't included are expendables like solder and flux, and you also have to use your own tools. So, first step to building really anything, but especially a DIY pedal kit, is to read the instructions. I cannot stress this enough that this document has been meticulously put together, especially in the case of Ion here. Kevin did a great job with this document. But you know, for any kit, these documents are put together to help you. There is a ton of information in here that will not only be relevant to this specific kit build, but there's information in here that you will carry with you onto every pedal you build going forward. Choosing to read this document thoroughly could be the difference between you ending up with a pedal at the end that works and a pedal that does not. And if you're saying to yourself, well, he's just saying that, but I'm sure he didn't read it, you're wrong. I did read this document already. And the reason for that is, as confident as I am that I could put this kit together without reading the document, I am even more confident that I am a human being who makes mistakes, and I have a dumb brain stuck rattling around in my head, and I can, like I said, I can make mistakes, I can get it wrong, and I can be overconfident in things I shouldn't be. So yes, I did read this document, and if you are a dumb human like I am, which I'm sure you are, then you need to read it as well. So we are going to move on to the next step, because like I said, I already read the document. You need to pause the video and start reading. I want to be clear, this is not a sponsored video. I bought this kit full price off Ion's website. I believe it was $86 and change plus shipping. And I want to be clear to my viewers and to any sponsors going forward that while I am not opposed to doing sponsored stuff, my integrity is not for sale, and I will never agree implicitly or explicitly to not say mean things about your stuff. If this kit here has some stupid thing about it, I'm going to tell you. If your item that you give me sponsored, it has some stupid thing about it, I'm going to say mean things about it. And to be fair, if it has cool things, I'm going to mention that too. So, yeah, that's my promise to my viewers, to myself, that my perspective, my beliefs are not for sale. And I will always tell you the truth. And of course, if there is any sponsored part of a video, I will always tell you about it. All right, so by this point, hopefully you've read through the document and you familiarize yourself with the process we're going to go through building this pedal. The next step is to confirm that we've received all of the parts we're expecting to receive, because if you are missing anything, you want to notify the person you bought the kit from as soon as possible so they can ship that out to you. What I will say about this is to double and triple check your count, because the fact of the matter is that they put these kits together all the time. This may be your first time counting parts in a kit. So if we're going to take a guess as who's more likely to have made a mistake, it's probably you. Double and triple check your counts, check your components if it's just a mistake or, you know, a discrepancy in value. You know, check your work. And if at that point you're certain that you are missing something, reach out to them immediately, because they're going to have to mail it off to you most likely. And it is no fun to be waiting to finish up a build because you're waiting on one part. Every kit build is going to include some type of packing list or bill of materials that will list out all of the specific types of components, value, and quantity of that value. You want to go through all your parts and check off one by one to make sure you have everything you need. So that's what I'm going to do now. If this is your first kit build and you don't know what a resistor is or looks like compared to a capacitor or compared to a diode or a transistor or an IC, this kit is really great because it includes a lot of really good information. But there's this sheet here of component identification, and this shows you a visual representation of all these components. You should take these and frame these and put them up on your wall, because this will help you for many pedal builds, not just this one. But anyway, if you're unsure what a resistor looks like, or a diode, trimmer, different kinds of diodes, capacitors, this will tell you what they look like, and you can cross-reference that with the actual parts that you received to make sure you got all the parts you need. So that's the step we're going to go through now. Is I'm going to go on this paper here, and I'm going to check off that I've received all the parts in the correct quantities. All right, I've confirmed that I've received all the parts that were meant to be included in the kit. I did think for a second there that I was missing a nut, but it was hiding under the battery snap. Hopefully you saw that. So yeah, I received all the parts I was supposed to get. Next step is I want to confirm that I have all the tools I will need in order to build the pedal. Because if I don't have a tool I need, I'm going to want to get that in order as well, so that I can continue with the build. I'm going to do a longer video at some point on all the tools I use and why, but for right now we're just going to make sure we have these. So soldering iron, I have my trusty Metcal SP200 here. Here's the wand, it's just sitting over there on my bench. Solder, can't go wrong with some Kester. Leaded solder, of course, because America. Digital multimeter, one of many. Trusty fluke, pop that there. Solder's there. Wire snippers, multiple pairs, but of course I have my tried and true Lindstroms. Flat nose pliers, right there. Needle nose, I use all kinds of different pliers. I'm just gonna include these. These are bent nose pliers. Screwdriver, Phillips, right there. Tiny screwdriver, right there. Need a rubber band for tightening the dress nut. Basically just to keep from marring up the finish on that nut. I do have a rubber band like that. Another option you could do for that is put some heat shrink over a pair of pliers, maybe a couple layers of heat shrink, and use that. So that is all the tools we will need. Let's go on to the next step. Okay, we are on the PCB assembly step here. So we're ready to start putting components in the board. Now that we've confirmed we have the tools and we have all the components we need. So first step here is to get your PCBs and separate off the boards. My input jack and DC jack board came already disconnected from any other PCBs, so that is ready to go. The main PCB and the Footswitch PCB are still connected. So to separate those, easiest way is just grab them, bend them apart like that. What you'll see is you're going to have these little nubs, a little flash, you can call it, left over from the PCB manufacturing process. You can just take needle nose and break those off, like so. If you want, you can also come in here with a piece of sandpaper, emery paper, and just clean up a little bit of rough edges there. Just be careful because the dust that is made from these epoxy boards is toxic. One step that I think is a good idea, even though it's not listed here, is to clean the PCBs. So you can do that with just a bit of isopropyl alcohol, 70% or better. Just put a little bit on a rag and just wipe off the PCB. This gets any oils or silkscreen residue, whatever, from the manufacturing process cleaned off the board, and will help you solder, because any impurities or extra gunk left over from the manufacturing can cause your solder to not wick to the board. So just grab some alcohol, give the boards a wipe down. After you've done that, try not to touch the board, try just to touch the edges like I am. Do that there. Footswitch PCB, you don't have to go crazy with it. I found that the boards from Ion come pretty clean. Some other manufacturers, not so much. But it's a good precaution to take anyway. Clean that off. Clean off the little input jack, DC jack board here. Okay. So, next step it says, ready to start populating. And it gives good tips here on the order of populating the board, which is to start from the smallest components and then work up to the tallest components. Reason for that being that it can be fiddly to try and fit in tiny little resistors when you have a bunch of capacitors standing up around that component. And if you have to do topside soldering, it's also difficult to get your soldering iron in there in between tall components to solder. So you start with the smallest components first, which is usually resistors and diodes are approximately the same size. And then you go to sockets, then generally film capacitors or ceramic capacitors, transistors. In this case, the build here has the transistor soldered straight to the board. I'm probably going to use some sockets just because I think it's a good idea for any type of semiconductors. And then usually last is going to be your tall electrolytic capacitors. So that's the next step. Let's do it. We will populate the board first. For the number of resistors we have here, which is approximately 20 or so, maybe 25, I'm going to do it in 2 steps. So put in 12, solder those in, put in another 12. The Ion kit actually has this nice sheet here that shows plugging in the resistors to the main PCB there. So instead of doing straight 10, I'm just going to go in the list of these columns the way they're listed here. So I've got the first 8 resistors, R1 through R8, laid out in order here, and I'm going to populate them into the board. So let's grab the first one here. First resistor, R1, is a 1 kilo ohm resistor. These resistors are nice because they show the value right there on the resistor. Now, admittedly, I'm a little bit anal when I populate PCBs, which means that I will take certain steps to have a certain aesthetic that is not necessarily going to impact the sound or durability of the pedal. But it is my belief that when someone opens up a pedal I build, I want them to be immediately aware of the fact that someone took time and care to put this pedal together. And it is a pedal that is going to sound good and last a long time. So specifically for resistors, what that means is making sure that the value of the resistor is always facing up, so it is readable, and all the resistors values face the same direction. And then when I mount them in the PCB, they all have to be even, not tilted to one side or the other, and the solder has to be even for the resistor legs underneath and on top. So that's what I'm going to do now. As far as folding over the components, you can see here the legs need to be folded perpendicular to the body of the resistor so that they fit in the matching holes on the PCB. There are different tools available that can help you do this. I have found that those slow me down more than anything. So all I do is I know, okay, I got the text that I want to face up here. I'm going to turn that to the side. I like to grab the resistor and just with my thumb come in there and bend it nice and tight angle to the side until it's a little bit past perpendicular, like that, a little bit past. So it's not straight 90 there, it's a little bit less than 90, you know. Same thing on this side, bending up until it's a little bit past, like so. And then once it's a little bit past, I just take the leg and bend it back to 90. And what that means is it has a tighter curve where it bends around the lead there. It's not a hard 90, and it's not stressing the leads more than it does stress a little more, but it's okay. And what it means now is it's going to fit very cleanly into the PCB. Like so. And of course, the resistor value is standing straight up. So this is R1. The board here shows you very clearly where R1 is, which is right here. I confirmed that on the board with the silk screen, marked R1 right on the side there. Could take our resistor, text facing up in line with the board. The board's going to sit in the enclosure like that, so I want the text to be readable. When I do that, plug in the resistor like so, push it all the way down. And then, if the resistor is a little tight, like it doesn't want to go all the way in, just grab from the bottom and just wiggle it. Pull it nice and taut. And then on the other side, you can take the leads and just bend them over. I don't usually go past 45 here, because if you bend them too far, the lead's going to lay on the board, and it just doesn't look nice. The solder never looks good. So I bend them about a 45, like that. And then on the top side here, you can see it's nice and even. It's not tilting to one side or the other. The resistor value is easily readable. That's what I want to see. All right, so I now have the first 8 resistors populated into the PCB. They're still loose, haven't been soldered yet. So now I need to find some way to hold the PCB while I solder to make sure the resistors stay in the orientation I want, and make sure the resistors stay flat in the PCB. I don't want one end or the other sticking up out of the PCB. So there's multiple ways to hold a PCB while you're soldering. One popular way is to use a PCB holder, like so. That's one of these devices here. These have jaws that sit on the side of the PCB. Don't work for every application. For one, they have a maximum size, but also sometimes components are too close to the edge of the PCB that your jaw will start pushing on them, which isn't good. Another option is to use a hobby vise or a vacuum vise. That's one of these devices here. They don't always have vacuum pads. They could have a bolt-on pad or just a weighted body. But these, they don't go as far in on the PCB, so they could be a good option if you have components close to the edge, but they don't hold it as securely, and they're generally more time consuming to use because you have to tighten and untighten. If you're flipping components and using different sizes, you have to go all the way in and all the way out to that, but that's another option. One option I think is very good, which is something I use a lot, is this sticky tack, or also called like poster tack or blue tack. I got this idea from, I can't remember. I'll remember their name in a second. They have a popular King of Tone board, Rolly Wow. That's the first time I saw this used, and it's a good idea. Nice part about this is you can mold it to really any shape, and you can also flatten out the putty like so, and take your board and push this down on top like this, and that will hold the resistors in place while you solder. The only downside to using this that I found is that you want to be careful on heat, because as you're soldering the components, it will heat up the putty, which gets soft and extra sticky and kind of loose, and you'll find that it leaves remnants, it leaves, putty on the resistors when you pull it off, or whatever component you're soldering. But you can always just take the putty, go back in and just dab it up and clean up the area. So this is what I'm going to go with here. I'm going to solder up these components now. As the instructions say here, if you've never soldered before, this isn't the time to learn on your kit build. Go and get some prototyping board or something else, watch a couple YouTube videos, and get an idea for what you want, or how you want to apply your soldering tip and your solder to get the correct amount and to get it to flow the way you want. This video isn't going to be an instruction on how to solder. It's mostly just showing, you know, how I build kits. So let's solder up this PCB. You'll see as I'm soldering, I like to jump around the board a lot, and that's partially because of just my experience with trying to limit the amount of heat I apply to any one component. When I jump around, I don't do multiple soldering jobs on the single component, which lets it dissipate heat while I solder other things. It's also, though, because I'm working with the constraints of this camera and how I'm configured here, and it's not always conducive to get my iron and my solder into that specific spot. So there may be certain pads that I will leave unsoldered for the moment, and I will come in, trim the leads, and then come back, hopefully unobstructed, and finish up the soldering. I can express to you how important a good soldering iron is. The soldering iron I use is a Metcal SP200. I've used that iron and other Metcal irons for basically my entire electronics career. I 100% stand by them. They're fantastic irons. So now I've soldered in all the leads for this board. We can pull off the tack here. In this case, it doesn't look like I warmed up any of the resistors enough to leave remnants of the tack. So don't have anything to clean up there. So now I'm just checking. I want to make sure and see that solder has flown up through the hole to solder the component on both sides of the board. I can see a couple that I'm going to want to touch up a little bit, and a couple look pretty good. And you can do that from the top side here. Just come in with your soldering iron and just apply a little bit of solder, or even just a little bit of heat, just to wick up through capillary action onto the top side of the board here, just so it looks nice and even. So let's trim off the leads now. So one tip, save your leads. I think you'll find this on pretty much every electronics bench. It's a little bin of lead cutoffs. You will always need jumpers for a spot, and they will never be as handy as you would like, but this is a step in the right direction. When you cut off your components, just trim them off right into a little a drawer of an organizer. Or just collect them up, put them in a little baggie. That's fine too. I remember at one job we used to use little Altoid tins for these. And I'm not getting super close to the board because one, I don't think it looks nice, and two, it's not really necessary. I'm just going right where the solder has met the lead, right at that junction at the end, and just nipping off right there. And as usual, as I start to cut off the leads, I see one solder pad that I missed, so I'm going to go back and solder that one in. And this is a good time where I might use my hobby vise to hold the PCB while I clean up some of these top solder joints, like so. The only downside of soldering topside is you'll end up getting flux around the solder joints. I use a special type of solder here called no clean solder, or no clean flux core solder, which the flux it leaves behind is clear, so it's not as visible. So that is the first bank of resistors, and you can see there they're all even. All the text is pointing up, none are cockeyed. They're all nice and flat to the board. Solder is even. That is what I want to see on my builds, and that's what I consider a baseline level of craft. You know, this is a good time to take yourself seriously and take your craft seriously. It's okay to go slow and get it right. You know, you're probably doing this kit build for yourself, so take your time to make something that you're really proud of. That's what I believe, and that's what I was taught by my dad, by the other people I've worked with. Having pride in your work is one of the many things that gives you fulfillment and esteem in your life. And, you know, as you practice that skill, and it's a skill just like anything else, when you practice that skill, you will get faster at it, and you'll start to be proficient in speed and quality work. But you have to practice it. If you practice going fast and sloppy, then you'll only get good at being crap. So put time in yourself and you'll get paid back. Okay, so we've now populated the main PCB and the Footswitch PCB with all of the resistors. Got them all facing up the same way, all evenly soldered, making sure solder flows through on either side. Actually, let's see a couple I have to touch up there. Take care of that. But next step here is the diodes. So there's only 3 diodes for the Luna project here, and that is 2 silicon signal diodes, 4148s or 914s, and a 5817, most likely polarity protection diode. The signal diodes are going to go here to D2 and D3 on the main PCB. The 5817 is going on the Footswitch PCB. So I'm going to solder those in now. For the diodes, often the spacing given on the PCB is significantly larger than the actual diode. So unlike the resistors where you could fold them over right where the leads meet the body of the resistor, chances are there's going to want to be a little bit of lead left on either side. So I pretty much just eyeball it. I just look and see, okay, how much extra space is there between the holes on the PCB compared to the lead, or compared to the component body. And then I may like use needle nose pliers like this to give myself a little spacing guide, and then just fold it over on the edge of the pliers. That protects the component from being stressed while bending the lead, and it also gives me the spacing I need to fit the through holes nice and easy. So let's do the diodes next. Also, I just mentioned that diodes are polarized devices. You can look, there is a little stripe, black stripe on the end of the diode that marks the cathode. The PCB here also shows you which direction the stripe should go. So for D3 here, the stripe should be on the left side. D2, the stripe should be on the right side. And as well for D1, the protection diode, stripe should be down. So make sure you get your polarity of your diodes correct, or they will not work correctly, and concurrently the pedal probably won't work right either. Okay, so the diodes are installed now. Next up is the socket and ICs. So installing sockets. The kit here includes these 8-pin dip sockets. So what's that? Dual inline position, whatever it stands for. It's 2 lines of 4 pins, and it matches up to the pins of a IC. In this case, there are a couple of dual op amps. Installing these sockets, so as the instructions say, you can't bend the pins, they'll just break off on these sockets, and so they are lined up to go exactly into the board. The problem is that if you can't bend the pins, the socket just falls out. So in order to install these, there's a couple different methods. One thing that you can do is, as you're installing the socket, you can actually just put your finger on the bottom here and come in and apply solder to one of the pads, or like diagonal pads on either end. That'll hold the socket in the correct position, and then you can go in and solder the rest, and then it'll be locked into place. Another thing you can do is use some more of this sticky tack stuff and go over top, holding it in place as you flip it over. Once you have one installed, and also be careful polarity, you can notice that the IC socket has a little notch in it, the same as the silkscreen. That'll help you orient the IC when we install those later. So we're going to put these two sockets in. One thing you can do, once you have one socket, you can sort of use that to help you install the second, because it sort of gives a flat platform. If you lay it down on the bottom like that and just push down on the PCB, that should get it pretty close to flat, and then you may just want to come in and touch up that holding or that tack soldering to get it nice and straight and flat. I am also going to install a socket for the JFET. So this is a piece that's not included with the kit, so don't expect this to come with yours. But what I'm going to use are these little breakaway socket pieces in here, or strips of their single line strip sockets, and you can break them apart. The nice little instruction manual does go over using these sockets, and like the manual says, you can use an X-Acto knife or some sort of hobby knife to cut these apart. So I'll demonstrate that here. What I like to do is I'll take this and I won't cut all the way through on either side. I will just sort of depress or make a little indentation with the knife on one side, flip it over to the same spot, and then cut through. What I've found is that if you try to do it once through on one side, it tends to just break the plastic as opposed to actually cutting it, which it's probably not a big deal. The plastic never seems to completely break away from the metal socket piece itself, but it just doesn't look as nice. So that's what I do, is I score one side, I flip it over, and then cut through. And so far it's been very effective to get nice clean cuts through the socket material. In this case, this PCB is designed to be able to use different pinouts for the transistor. That's why there's 4 holes for a 3-hole or a 3-lead device. I'm going to fill up all 4 of those holes just in case for some reason I end up having to replace that transistor at some point with a different pinout. I want to have a socket there just in case. So we're going to cut 4 sockets off of this strip using the knife technique I described. All right, so here is our 4-socket little strip. Getting these into the PCB is a little more tricky because you don't have sort of 2 points of contact. So getting these to be nice and straight is a little harder. Now, one cool thing is that the height is the same as the dip sockets. So you can use those, which are already installed, to sort of line it up at least perpendicular to the board. So that's what I'm going to do here, is kind of hold these in position while I lay it down here. And then I'm going to push down on the board while installing these, which should ideally line them up 90 degrees to the PCB. And worst case, if it's not quite right, I can come in later and touch it up, make sure it's aligned correctly. All right, so yeah, you can see there, it's pretty close, but not close enough for me. It's just slightly tilting that way. So all I'm gonna do is come in here with my finger, and while holding the PCB, I'm just going to touch that pad again and hopefully line up the sockets, not burning myself in the process. Like that. There we go. Now that's nice and straight, just how I want it. Okay, cool. So now that that socket's in there correctly, I am going to finish up soldering. With these sockets, there's nowhere for the solder to flow on the other side of the pad. So you only really need to apply enough solder to get it to give a nice fillet on this side of the PCB. So you can see that, hopefully. So there's our socket for the JFET transistor. Next step in the manual here shows installing the transistor. And if you're not socketing your transistor, you would want to install it now because it's the next up in height. Because I have sockets, I'm going to wait until I install the ICs to install this transistor. But I will show bending of the legs here. The way it's described in this manual is the same way I do it, which is to use a needle nose plier. So sometimes transistors will come like this here, where the outer transistor legs, usually emitter and collector, or collector and emitter, whatever, are already bent out for you. They already give the 0.1 inch spacing or 1/10 spacing for normal PCB spacing. However, sometimes transistors come as this one did, where the legs are closer together. So we're going to use the pliers here to bend out the leads. We'll make the first bend by grabbing and bending outwards, and then while still holding onto the transistor, we'll then bend the lead back to be parallel with the other leads. So that's what this looks like. So we're going to take this lead and we're going to bend it out first, like that. And while holding on, we're going to bend the lead back, like so. Same thing on the outside lead, bend it out, and then bend it back. Ideally, it should be nice and evenly spaced. Looks like a factory machine did it. Knowing how far to bend it out angle-wise just takes practice. You don't want to bend the legs too frequently, but worst case, you can always fudge it a little bit. You don't have to get it pushed down totally flush into the PCB here. When you're soldering it, it can stick up a little bit out of the board, and normally does, as the picture shows here. So that is how you bend the leads on a transistor. All right, next up are the capacitors, the non-polarized capacitors. So there's no specific orientation for these caps. It's going to include film caps, ceramic caps, the main two types. There's only 8 caps to install here, so we're just going to bang all these out together. I don't really have any special considerations for these caps. Sometimes the leads will be shorter like this, where it's cut-offs from a tape reel, or you'll just get the tape reel separated with the cap still attached. Either way is fine. The leads are shorter, so when you're putting them in the board, just be careful. It can be stiffer. You don't want to poke yourself. And make sure to push down on the capacitor while you're bending over the leads so that the cap stays nice and straight and flush to the board. Also, one thing I do is, especially for the WEMA caps where the value is written on the side as opposed to the top, I will pick an orientation. Because they're not polarized, I have a choice between mounting in the board like this or like this. I will pick the side that makes the value and voltage rating in this case more visible. So if I were to insert into the board like so, you can see the value and the voltage are obstructed, can't read them. If I flip it around, however, you will be able to read that because there's a bit of space here between the cap and the optocoupler. So that's how I'm going to install it, and then I'm going to be careful. I want the capacitor nice and flush to the board. I want it standing straight up. I don't want it cockeyed, and I want it to stand straight up and perpendicular to the board. So let's get those caps put in here now. All right, so I've got all the film caps and the one ceramic cap populated into this Luna board here. If I'm concerned about the orientation of the capacitors, which I am generally, what I usually do is I come in and I tack one side of the capacitor, so solder just one lead of the capacitor, and then I can flip it over and make adjustments to the position or orientation, or if necessary I can come in, reheat or reflow that solder and just push down on the cap if it's pulled away. And I can also grab with some needle nose gently and just twist them into place. Ideally, if it's too cockeyed, you want to come in and heat the solder and then twist it. But if it's just a little bit off, you can just kind of coax it into parallel so they all stand up nice and straight and even to the board. And it also doesn't look cockeyed compared to the silk screen. So let's solder that up now. All right, so we've got the film capacitors all installed now. As you can see, they are all straight, flush to the board, standing straight up. All the values are as readable as possible. So you can see, like, for example, here, I have these two caps. I could have turned the value of this cap and this cap in towards each other, but then they would have been really hard to read. But now with them facing out, they're super simple to read. You could do that with non-polarized capacitors or just generally non-polarized components. This cap could have been turned the other way, but it's far enough away from tall components that it doesn't really matter. All right, got the non-polarized capacitors installed in the main PCB and the Footswitch PCB. The next step in the kit is listed as the wire headers, which are the male connectors here for the wire assemblies. So these little pieces will connect to the daughter boards, in this case the Footswitch, and it will just clip in with wire connections to the main PCB here. I am going to hold off on this step. My concern here is if I install this wire header into its appropriate spot on the board, I'm going to have a very tight fit to soldering that potentiometer there. Same thing on this side. If I put this wire header in, it's going to be a tight fit. It's not as bad on this side because I can reach over the resistors, but on this side I have this capacitor in the way. And getting into that inside lug on the smooth pot may be a bit of a challenge and what I really want to avoid is burning the sides of my capacitors. That's a huge pet peeve of mine. It's totally unacceptable to have that on a build personally. Will it hurt the capacitor? Will it cause it to fail? Probably not, but it looks terrible to me and I don't want that to happen. So I'm going to hold off on installing these headers, or at least the left side header here, until a later step. It may make it harder to install this later, but I do not want to burn that capacitor. So I'm going to wait until that smooth pot is installed until I install this header. I'm going to go ahead and put this one in, however. Okay, cruising right along. I've got the one header in there. Like I said, I'm going to hold off on the left side header here. Next step is the polarized capacitors and the Vactrol. The silk screen on this main PCB is very good. It tells you exactly how the Vactrol has to be oriented. And in this case, it shows the positive side for the anode of the diode, and the actual Vactrol here says LED. The Vactrol, or the optocoupler, whatever you want to call it, is a combination of a LED, light emitting diode, and a light dependent resistor, LDR. And as the LED increases, it usually causes the resistance on the LDR to go down. The light dependent resistor is still just a resistor, non-polarized, so that could really go in either way. However, the LED is polarized, it's a diode. And so you want to match up the positive mark anode to the positive mark anode on the optocoupler. As far as mounting them, I'm going to do sort of the same thing I did with the diode, which is kind of eyeball it and see how much space I have either side of the leads to figure out where I want to bend. It looks like there's not much space, so it's going to probably be just a soft bend with my hand over to a 90 degree. For the polarized capacitors, they are polarized, so you want to make sure you get the orientation correct. On these capacitors, most polarized capacitors are going to have this heat shrunk film over the outside. It'll give you the capacitance, the voltage rating, and there will usually be a stripe, which is the negative or the cathode side of the, I wouldn't call it negative or cathode, it would just be the negative side of the polarized capacitor. So that is going to go into the side that's not marked with the plus. So the positive side of the cap would go to the plus side like so. And then sort of the same rule for the film caps. I want it standing straight up and down. I don't want it tilting to one side, and I want it to be flush to the board without a gap beneath. Some people do like to leave a little gap underneath. I don't do that because, number one, usually these capacitors are designed with a little spacer there that's intentionally meant to be put against the PCB. And if you leave a gap, you just run the risk of having a solder bridge underneath the cap, which is really hard to clear out. So I do not leave any gaps. I push it down flush to the board. And I might use the same trick I did before with the film caps, which is tack in one side, come back, check the orientation, give it a little twist or turn or push to get it standing up straight, and then solder on the other side. So let's do the caps and the optocoupler now. Got the polarized capacitors and the optocoupler installed on the PCB. Next step is to add these wire assemblies to the Footswitch PCB. There is 2 banks of 3 solder joints there, or solder pads, and then a bank of 4 in the middle. And to match along with that, we have 2 3-wire assemblies and 1 4-wire assembly. Instructions here are pretty clear. But as you put these in, there is a strain relief built in. It's actually a strain relief, but it also helps you because it sort of holds the wire in place in the solder pad. But the way it wants to go is it wants to have the blue marks here on the wire assembly. It wants those facing out if you're holding the board like this. So what the instructions are saying here is you're going to take your wire assembly, you're going to insert it into the oval-shaped cutout like so. See that go through there? And then you're going to take these wires around and bend them like so. These wires are already stripped and pre-tinned for you. It's why there weren't wire strippers on the tool sheet. So you take them, insert them like that, and pull the wires through a little bit so you have enough slack to reach over to the main PCB. At this point, you can also take these and just bend them a little bit this way so they're sticking straight up. Now, these wires assemblies are a nice, fairly heavy gauge wire for wire assemblies. Looks to be probably 22 gauge. However, it is PVC insulation. That's the outer material on the wire. And PVC melts very easily, especially under the high heat from your soldering iron. So you need to be quick when you're soldering these if you're not going to melt the insulation. Melting the insulation does not hurt the wire at all. However, it looks like crap, and it's another pet peeve of mine. So what I like to do is I like to come in and be very quick. Essentially with my soldering, there's not really a trick to it besides just be quick. Heat up the wire and solder them in, and ideally not melt the insulation. That's the goal. So let's go ahead and install the rest of these wire assemblies and then solder them up. Actually, I'm going to do one at a time just so I'm not fighting the other wires while I'm soldering. Okay, got the wire assemblies now soldered onto the PCB. All the loops are approximately the same length. Strain relief built in there. And the solder pads, I like to have enough solder to fill up. I don't want to see any gold or any of the underneath color on the solder pad. Moving on to the input and output PCB, we're going to install the two PCB mounted 1/4 inch jacks for input and output connection, the PCB mounted DC jack 2.1 millimeters, and the battery snap. These are pretty straightforward. They are the same, so you're just going to fit them into the appropriate mounting holes on the PCB. They have little locating tabs, so they should pretty much just go in there, and you shouldn't have to really hold them. They should fit snugly. Same for the DC jack. The battery snap here, the way they want you to do it here in the instructions is to take the wires like so and feed them through. What you're going to do here, you can see on the bottom, you essentially are kind of tying a knot around this hole. So you're going to come up through the hole here, come back around and through the hole again, and then wiring it then into the soldering pads. There's plus and minus, red is plus or positive, black is negative. Okay, so I've got the input and output jacks wired to the PCB here. The last step, it says on the instructions here for the this input and output jack board, is to snip off the leads that stick through for the input and output jacks. So that's 1, 2, 3, 4, 5, 6. And that's because this board will sit on top of the main board when it's installed in the pedal, and you don't want those leads to touch any of the components or to prevent you having to like smush it into the board in order to fit it into the enclosure. So this is where a good set of cutters is going to make your life a whole lot better. You want to be careful too, because specialty electronics cutters like this pair of Lindströms, they are not designed to cut strong metal or hard metal. These are specific for copper, tin, and soft alloys. A nice pair of diagonal cutters. These are Knipex, made in Germany. I've had these for a long time. These give you a ton of leverage, and it's going to make quick work of these little leftover leads. So just come in here, snip them right off. They are a large cutter, however, they are made well enough that I can go in here and make tiny little correction cuts just to get as close as possible to the PCB. And over here as well. It's a good sign that you're using the right cutters. If you hear a snap when you cut it, that is a sign that the metal is too hard for electronics cutters. Okay, looks good. So now our leads are nice and flush to the board, at least as much as they can be. They are a little bit sharp. That's just one of the downsides of this cutter, is it does leave a little sharp. If you're concerned about that, you can always come in either with a rotary tool like a little Dremel and just give it a file, or just, you know, touch it with a little bit of like emery paper like this. Just kind of come in here and clean out the sharp edges if you're worried about that. It's going to be underneath the board, so I'm not too concerned about that. Blow off any little extra pieces, and now the input and output board here is ready to go. Oh, looks like we're also going to install the 4-pin header at this step. Okay, the next page here goes over the orientation or order of components for the different off-board components, and also the potentiometers, the grommet, or the bezel for the LEDs. So for example, the Footswitch here, it shows that you should have the inside nut and the lock washer on the inside of the enclosure, and then the outer nut and dress nut on the outside. Potentiometers down here, it's going to be the pot and then the lock washer, and then on the outside of the enclosure, the outer washer and the mounting nut. It also shows here that instruction manual here recommends installing the components into the enclosure here, which is a good idea for the potentiometers, and obviously the bezel has to be installed, LEDs as well. However, for the Footswitch, I'm going to deviate a little bit here just because it's a big pet peeve of mine to, I know I have a lot of pet peeves. It's a pet peeve of mine to see the Footswitch not evenly spaced inside the little, the through holes for the solder lugs on the Footswitch. On this Footswitch, it just happens to be the case that the spacing on these lugs is a little bit narrower. It is ever so slightly narrower than a standard Footswitch here. And so while this Footswitch conveniently doesn't move back and forth much in the Footswitch PCB, so you can't really get it wrong. It's actually kind of nice. A standard 3-pole double throw does move around a bit inside normal socket holes, at least the ones Ion include here. Tighter holes obviously would not allow as much movement, but then it also wouldn't have tolerance for more sloppy, I guess, Footswitch manufacturing. So you want those, when you're designing the PCB, you want to leave those holes big enough to account for that sloppiness, but it also means that you can have stuff where you get it like that, where the Footswitch is clearly soldered towards the top or left if you're facing the PCB, and that annoys me. So I prefer to install the Footswitch outside of the enclosure, just by holding the Footswitch in a vise, and then I can very carefully control how the PCB mounts onto the Footswitch so that I make sure it's all, not only that it's straight and even, but also that it's flush to the Footswitch this way. Cockeyed PCBs are really annoying as well. So that's what I'm going to do. I'm going to install the Footswitch outside the PCB, or outside the enclosure first, even though the enclosure recommends differently. For the pots, definitely want to install in the enclosure, because trying to put in 6 PCB mounted pots outside the enclosure would be near impossible. So when soldering Footswitches like this, you don't want to go and just bang out all 9 in one shot. That's a lot of heat you're putting into a small component that is, the lugs are held in with epoxy that is sensitive to heat. So what I'm going to do here is I'm going to get this PCB positioned where I want it to, which looks about correct right there, nice and flat to the board, like so. Our PCB nice and flat to the Footswitch. And then I'm going to come in and just put a little bit of solder right on the middle one. And then I'll probably let that cool for a second, and then I'll come in here pushing down to confirm that the PCB is flush, reflow that solder, and then let it cool, and then the PCB will be affixed in the correct orientation to the Footswitch. Then what I usually do is I do a cross pattern. So once that middle one is set up, I'll do the 2 corners. That'll really lock the Footswitch in place. And then I'll do the opposite corners, and then I will fill in the middle lug, so that's 5. And then I'll wait a couple minutes to let it cool down, and then I will do the inside lugs. So I'm not getting too much heat all at once into the Footswitch. As far as the actual solder procedure, you want to be careful too. You want to feed your solder in at a nice constant rate, fill up that hole, and then get your heat off. You don't want to hold your heat there for more than a couple seconds. All right, so now I've sort of tacked that into place. I'm going to come in here, pushing down lightly on the board, reflow that and move just a tiny bit, which is good. I'm going to pop it out of the vise quickly just to check that the orientation looks good. Yeah, nice and flush to the board, that's what I want. And pads look evenly spaced, which is good. Put the PCB back in the, or put the Footswitch body back in the vise here. And now come in and solder the four corners. It can be difficult because you want to wait and see how the solder is going to flow, but you don't want to apply too much heat. So I'm totally fine with that. Having good mechanical connection with solder is just as important as the electronics for a component that you're going to be stepping on a lot. All right, so now I've got the 5 solder pads soldered in, and you can come in here and feel the body of the Footswitch. It is quite warm to the touch. And that is why we're not going to put any more heat on it for a couple minutes. We don't want to melt the epoxy that's holding those lugs in place. So we're going to let it sit like that for a couple minutes. Or if you have a little fan, you can put it on there, wait 30 seconds, probably good enough. And then we'll come in and fill out the remaining four solder lugs. Okay, so got the Footswitch mounted to the Footswitch board. The other boards have reached their point of being ready for the next step. So now we're going to put the components that are remaining inside the enclosure here, and then we're going to attach the PCBs built into the enclosure like so. As the document explains here, that it's usually a good idea to test your PCB before you mount it in an enclosure, but the way that this pedal is designed is that you can easily remove the assembly from the enclosure after you've soldered it. So that's the reason you usually rock it before you box it, which is because building it into the enclosure often means that it can be difficult or impossible to get it out without desoldering stuff. But that's not the case in this pedal. In this case, you can remove the innards easily even after soldered. So according to Ion, you should box it before you rock it. So let's get the PCBs plugged in. But first, very important step, do not forget this. I promise you will, and you will remember me saying this, but do not forget to put your pot covers on the potentiometers. These pot covers protect the back of the potentiometer here from shorting out to the PCB. Just a little piece of plastic. Now for these pot covers, they do have an orientation. You can see on the pot cover here, this bottom side has a little cutout, and that matches up to the opening inside the potentiometer. So that little cutout is going to go, and you can see that it's actually got a couple little nibs. That's going to go around the middle lug or the wiper of the potentiometer. So this kit includes all 6 to cover all 6 potentiometers. So I'm going to put one on each. Sometimes you may not need the covers for like these 3 potentiometers just because they're not actually under the board. But since they're included, I'm going to put them on. And then we're going to put the potentiometers in the box as well as the LED bezels, and then just sort of finger tighten them into place. That way all the solder pins will be sticking up, and then we'll just drop the main board onto it and solder it into place. Okay, so I've got the potentiometers and the 2 bezels installed into the PCB. I've taken the time to both straighten the potentiometers inside the enclosure and make sure the pins of the potentiometers are sticking straight up. If they were bent in shipping or whatever, make sure to bend them up because it'll make it easier. If they're sticking up nice and straight, then the main board or the main PCB should drop right onto the pins, like so. So the next step is to solder the PCB onto the pins, but you'll notice here that the board is rocking a little bit on the PCB, on the pins for the potentiometers. And that's just because that not all the solder pins are the exact same height underneath the PCB here. And so they're sort of floating on the covers for the potentiometers. Not really anything you can do about that. What I really care about is that the PCB looks nice and straight in the enclosure here. And of course that there is enough pins sticking up through the solder holes for the PCB to get a good connection. So I'm checking the PCB both sideways and front to back to make sure it's nice and level. And you can always do the trick we talked about before, which is to like tack in one of the solder joints and just use that to hold everything in place. There's enough friction here where I can manipulate it and it sort of just stays in place at least long enough to get one solder joint in. And again, this is one of those aesthetic things that's just like a pet peeve of mine. As long as you get good solder on the pins for the potentiometers, if the PCB is cockeyed in the enclosure, it's not going to sound different or be less durable. It looks a little sloppy to me. That's why I take the time to make sure I get this right. So I'm going to come here and solder in a couple of these pads, being careful not to move the PCB as I do this. Also being careful to not twist my iron here so that it touches any of the components. Like I said, a burn mark on these capacitors especially is a really ugly thing to see inside a build. And see, this is where I benefit from not installing that header yet, is I can come in this way and have easy access to these solder pins for the smooth control here. If I put that header in there, I would be like up like this, and I'd be risking burning this capacitor. So that's why I waited. All right, let's check and see. Yeah, PCB looks very straight to me there. Okay, I'm gonna fill in the rest of these potentiometer solder pads. All right, so now I've got all the potentiometers soldered into the main PCB. So now this is where if you put in that header, you can move on to the next step. However, I have to get that header in and I can't get it in now because the pots are holding it in there. So now I've got to take the board back out of the enclosure here, which is no biggie. That's the nice part about designing like this with the PCB mounted components, is the whole thing is just going to lift out as one unit now. It's a little bit annoying to have to undo all the nuts and everything, but that is a very small price to pay to get what we initially left the header out for, which is to prevent melting the components, which I successfully did not do. So let's put in that header pin now, or the header jack. The instructions also say to cut off the remaining solder pins from the potentiometers here so that they adequately clear the input or output jack. So let's do that. Again, these are too hard for electronic cutters, so make sure to use appropriate cutters with hardened jaws so that you don't wreck your nice electronics cutters. Actually, these are even a little big for this job. So what you can use is end cutters. Now these are electronic cutters, however these are really old and beat up that I pretty much use for explicitly this purpose. And they, instead of cutting sideways on the cutter, these cut on the end. So that I can use them like this. And just nip off the ends of these. And like I said, this is too hard for these type of cutters, but these are old and mangy anyway, so. All right, that should be good. Now, I'm gonna go ahead and put this back in the enclosure. They should just pop right in. Make sure to put your lock nuts on, or the lock washers on first. My recommendation at this point would be don't go and tighten these down to full tightness. It's sort of like bad luck, because chances are if you go and do that, you're gonna have forgotten something, and you're gonna have to take these off again. So my recommendation is still at this point, just finger tight. No reason to go past that. When you're sure that you're done and you're ready to put on the knobs, then you can tighten it down with a wrench or whatever. All right, let's get the foot switch in there. So foot switch, it's gonna be a nut. And the lock washer. Actually, we want to get the LEDs in there. So LEDs, let's see. What color do they want for what? I'm gonna go back in the instructions here. I don't remember what color they are doing for what. All right, so maybe I'm missing it in the instructions, but I don't see anywhere where it actually specifies which color LED for which job. So I had to go on Aion's website and look at their example on their the picture there, and they are doing red for the rate, which is going to be the left LED if you are facing the inside of the box. Red there, and blue for the status or indication on off. LEDs, like all diodes, are polarized, and you can actually see on the silk screen here, it wants the flat edge on the let's see, so it would be on this side according to the silk screen there, flat edge, and the flat edge is the cathode. Another way you can tell is the length of the leads. The longer edge, or the longer lead, is the anode. The shorter lead is the cathode, and the cathode has the flat side. So that's what we want there, with the cathode going through the flat side, like so. One thing you can do, it can be kind of fiddly to like have the LED in the box first and then try to like fit this in here while you're trying to get the foot switch in. So one thing you can do is actually bring this into the PCB first, and then right at the edge, just give it a little bend, like so, like that, just to keep it from falling out, like that. There's usually plenty enough lead. If you don't have a long enough lead, you can't do this, but if they're new LEDs, they should be fine. And yeah, so this one, we're gonna put that in there. And same thing, just bend. You wanna do it right at the edge so you don't run out of space. So now the LEDs are just sort of dangling off. I'm gonna come in here and actually snug this down. Expressly for this purpose, I have these plastic sockets. People have asked me what these are. These are called rocket sockets, and they are sold. I got these from Love My Switches. They have these rocket sockets. They are great because they're plastic. They are strong enough to give you the torque you need on most of the fasteners for the pedal, or all of them, but they will not mar up your nice finish on your custom enclosure here. So another thing to check while you're installing these, you want to snug it down pretty good, but you want to make sure that that PCB is nice and straight. in the enclosure. Again, another aesthetic pet peeve sort of thing, but I do not like crooked PCBs. So I want that to be nice and straight. And then hold that into place, snug that up pretty good. Don't want that moving. And then there should be enough space in here for the 9-volt battery. Let's check that. Yep, plenty. I'll show you a little trick for getting those 9 volts to not rattle around on a finished build as well. Okay, and we'll put the dress nut on. Now the instructions say to use a rubber band to help you tighten the dress nut, which that's fine. Dress nut's for aesthetics, so we want to be careful not to mar that up. And what it probably means is just to use it like this, just to give you grip. And so just tighten it like that. If you really wanted that dress nut to stay in place and you're certain you don't want to take that off, you could use a bit of thread locker, like blue Loctite. This stuff here, like that. I would recommend against it because there is basically no purchase on this dress nut. And if you put that thread locker on there, you may never get it off when you need to. So you may end up having to like cut slots in it and use a tool or something. So I would say just make a habit of every once in a while just coming in here and making sure that that dress nut is nice and tight. And it's actually a bit frustrating here. I can see that the silk screen that was printed on this enclosure isn't quite even. I don't know if you can see that. The hole is a little bit down and right, or the silk screen is up and left. It's very slight. You wouldn't notice it unless you really went looking for it, yeah, it's one thing I notice. Not ideal. It's just kind of annoying. Obviously, not going to affect the pedal in function at all. It's just one of those little things. You know, you're going to the trouble of putting this nice dress nut on there, and nice knobs, and have a custom enclosure. Getting that silk screen nice and concentric at that hole, while I understand it's difficult, it is important because it's, if you look at it, it's pretty obviously off center. All right, so let's solder on the LEDs. Just one last double check to make sure you got the polarity of the LEDs right. Now is the time. Now, one thing about the LEDs is here is you'll notice that the LEDs will stick out a little bit from the end of the bezel here. That is fine. It's not going to hurt anything. However, I don't really like that. I prefer the LEDs to sit inside a bit because what that does is the light from the LED reflects off the inner chromed part and it just gives it a different look. I prefer that. So the way to make that happen is to put in a little bit of solder on the lead and then grab it and lift it out a bit. Or you could also come in here with your finger and just push in on the LED and reflow the solder on that pad, and then it'll stay in place. And then you solder the other pad, that'll lock it in and reflow the one you just did. That's what I'm going to do. So let's do that now. All right, so now they're fixed in place. I'm going to come in here and just putting light pressure on the LED. I'm going to push up and reflow that solder and then let go. So now you'll see the LED is sitting inside that chrome bezel, and when it lights up, it's going to sort of glow around that ring inside. And also, nothing can hit that LED now because it's sitting inside of the bezel. Do the same thing for the status LED here. There we go. So now they're both sitting inside that chrome bezel, like so. Come in here and lock in that position. And then once that pad is solid, you can come in here and just touch up that other pad if necessary. Cool. So because of those wire headers, that should be it for the soldering operations on the pedal here, assuming everything is built correctly. We're going to nip off the remaining leads, connect these wire assemblies, install the semiconductors and the ICs, and install the input and output board, and it should be at that point a functional pedal. We'll install the knobs if we are all good, and tighten down the nuts first, of course, just to make sure that the potentiometers don't come out. Let's get started on that. One last thing we didn't go over, this kit includes two ICs, 8-pin dip packages. And when you receive these ICs new, the pins are not, they're not perpendicular to the body of the IC. And so you have to bend them to make them nice and straight to fit in the sockets. The best way to do that is to take them on the table here and put the legs flat on the table, and then slowly bend the body of the IC up until they do get perpendicular. If you do like I did just there and go a little bit past 90, it's not a huge deal, but you do want to be careful. Ideally you don't do that because you only get so many bends out of these legs. But if that happens, just come in here with some needle nose and just straighten them out a bit. It's not a huge deal. And then coming again, this time I'll do it for real. Just make them nice and straight like so. So now you have nice 90-degree pins, and then you can insert this into the enclosure. And then pay attention to polarity. In this case, this Texas Instruments TLO72 has a little dot on the top left. That means the orientation is up this way, and that matches the notch. For these sockets, you want to make sure all your legs are in the correct position, and then give it a good push, and it should snap, but not snap. It should just push softly right into place, like so. Rinse and repeat for the TLO22. Again, we're just laying it flat, and be nice and gentle and controlled. These are fragile pins, so be careful. All right, that looks good enough. Same thing, come in here, drop the IC into the socket holes like so, and then just push down, and it should pop into place. All right, so got the two PCBs and the actually three PCBs, input and output PCB, Footswitch PCB, main PCB, all wired in. Got the 9-volt or battery snap, 9-volt battery snap routed down and around. That's all mounted in. Clearances are good. ICs are put in, and the transistor. All the wire assemblies are connected into their headers. So it is the moment of truth. Of course, all the fasteners have been fastened down. It's a moment of truth. It's time to give the pedal power and see if all the time and attention and patience and care we put into the pedal was worth it. This is where you find out if you did enough preparation to prevent yourself from having to deal with a whole bunch of troubleshooting. So let's find out. And this is my first time powering it. You and me are going to do it together. Here we go. Okay. Looks good so far. We have LED indication. Light turns off. The rate knob is, or rate LED is fluctuating or oscillating as it should be. We try turning up the rate knob and we should see that flash faster. Yep. It's good. Let's try, the symmetry should change the way this is flashing, I would imagine. Also seems to have an effect on rate, which is possible. Yeah, spacing you can see is changing sort of the interval, like the width. So it's on, like a long on and then short off. And then if you turn it here, it's a short on with a long pause in between. Depth may not have an effect on the LED. Anyway, and then LED turns the pedal on. Nice. So every indication so far is that the pedal is working correctly. Next step would be a listening test. So let's get some guitar and amp setup going so you can hear this pedal in action. All right, got the Luna now built, wired up, ready to do a little listening test. I have a Les Paul Studio. I've got a modded Bassman style amp with an SM57 a bit off axis pointed at the dust cap. There's a little bit of hum because I have a big old transformer right outside my window. A little bit of hiss from the pedal. Not a crazy amount though. Let's just set the knobs at noon and see what we get. That's interesting. So the spacing knob, it stops the effect there right around the 8 o'clock point, or 8:30, and then comes in right at the 9 o'clock. Yeah, so it sounds pretty good. Pretty standard optical tremolo sound. That spacing knob is interesting. It's sort of affecting, it feels like the sort of width of the LFO, like how wide the pulse is, but Yeah, it's interesting how it cuts out there. Let's take a quick look at the schematic and see why the effect may be stopping there at that position on the spacing knob. Figured out the problem with the spacing control. I had the ICs backwards. So I read it off here as IC1 TL072 and IC2 TL022 and just assumed that IC1 was above IC2, but that is not correct. IC2 is actually above IC1. So I had the 022 here, or excuse me, I had the 072 on top and the 022 at the bottom. Flip the ICs around and spacing control works across the whole sweep. So it just goes to show I make mistakes. Got these backwards. In this case, the pedal worked because 072 and 022, they're both dual op amps. In another situation where they were different kinds of ICs, it may not have worked at all, and it also could have potentially damaged one of the ICs. But in this case, it just made that spacing control not work correctly. A nice added bonus is now using the 072 in the signal path, the pedal is much quieter. That self noise went away, or if there is, it's really small. So that was just a mistake on my part, put the wrong ICs in the wrong spot. And of course, last step, certainly but not least, usually would save this to when the pedal is actually done for sure, but it looks pretty good so far, is to sign the pedal. You made this with your own hands. That is nothing to shake a stick at or ignore. It is a serious accomplishment. You should be proud of yourself. If your pedal is not working at this point, there is troubleshooting documentation inside the kit document here. Go through that. If you're still having trouble, put a message out on DIY stomp boxes or free stomp boxes or the Facebook group they mentioned or Reddit, the DIY pedals subreddit, and the nice people there will help you out. I go there from time to time and help people. So, but assuming your pedal is working, go ahead and sign your pedal. So let's see, it is. I'm going to put the date of 03/22 and then put my name. There you go. You earned that. This is yours. This is your creation. Be proud of that. It's an accomplishment. All right, so that wraps up the build on the AionFX Luna. If you have any questions, feel free to leave them in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. Also, don't forget, this pedal is available for sale. Check for the reverb link in the description. All the proceeds are going to go to humanitarian aid in Ukraine. I'm Joe from Graybench Electronics. Thank you for watching.